Welcome to Lesson 3 of Linux Mastery, the one where kill 9 stops being your first instinct and becomes your last resort. Every running thing on Linux is a process, and every process has a parent, a state, and a set of signals it can receive. Over the next 13 minutes, we'll cover 4 pieces: the process model itself, the tools to see what's running, the signals that control them, and finally background jobs. By the end, you'll debug runaway processes from causes, not symptoms. Let's start with the model itself. Every process on Linux is born the same way. An existing process calls fork to clone itself, and the clone calls exec to become a different program. That's it. A 50-year-old pattern that explains daemons, shells, even init. When you type ls in bash, bash forks a near-identical copy of itself, and that child immediately execs into the else binary. Same PID, brand new program. Each process carries its own PID and its parent's PPID, so the kernel always knows the family tree. And when something goes wrong, you get zombies, dead but unreaped, or orphans, adopted by PID 1. Remember that distinction. Only zombies are actually a problem, and SIGKILL won't help because they're already dead. So if fork builds the family, this is the family portrait. On the left, every process traces back up through its parent to PID 1, system, in one unbroken tree. On the right are the signals that travel down it. SIGHUP says reload, SIGINT is your Ctrl+C. SIGTERM politely asks a process to clean up and exit. That's what plain kill sends by default. SIGKILL is the kernel pulling the plug, no cleanup, no goodbye. And SIGSTOP just freezes the process mid-step until you let it continue. 2 halves, 1 mental model, where a process lives and what you can say to it. Now that you can picture the tree and the signals, you need eyes on it. And there are 3 tools, each answering a different question. PGID gives you a snapshot, a frozen frame of what's running right now, perfect for scripts and grep. Top is the live feed, refreshing every few seconds so you can watch CPU and memory shift in real time. htop is the same idea but interactive. Arrow keys, colors, a tree view you can scroll through. And when you just need a PID by name, pgrep and pkill are your shortcuts. The columns that matter across all of them: PID, PPID, %CPU, %mem, stat, and command. Once you can see processes, you need to talk to them. And that's where kill comes in. The name is misleading. Kill doesn't kill anything, it sends a signal. SIGTERM signal 15 is the default. A polite tap on the shoulder asking the process to clean up and exit. SIGKILL, signal 9, is the kernel pulling the plug. No cleanup, no goodbye. Between them sits SIGHUP for reloading config, SIGINT for your Ctrl+C, and SIGSTOP and SIGCONT to pause and resume. The rule: always start at 15, escalate to 9 only if it ignores you. Never start at 9. Now, signals also explain something every shell user hits daily: background jobs. Append an ampersand and your command runs in the background, handing the prompt back immediately. Jobs lists them, FG %1 pulls one forward, and Ctrl+Z suspends. That's literally SIGSTOP from the previous slide, with BG sending SIGCONT to resume. The catch? When your shell exits, it sends SIGHUP to its children. So for long jobs over SSH, wrap them in no-hup or disown them. Otherwise, that hang-up signal kills everything on logout. Which brings us to a tool you've probably glanced at without really reading: the stat column in PS. Every process carries a 1-letter state, and learning 4 of them changes how you debug. R means running or runnable. Healthy, usually transient. If it sticks at 100% CPU forever, that's a busy loop. S is sleeping, waiting on network, disk, or a signal. And it's where most daemons live their lives. Then come the 2 that matter most. D, uninterruptible sleep, stuck in the kernel on I/O that isn't coming back. SIGKILL won't touch it, you have to fix the I/O. And Z, the zombie, already dead, just waiting for its parent to call wait. Killing a zombie is meaningless. You fix the parent. Step back for a moment, because everything we've covered isn't really about Linux. It's about a model that quietly runs your entire stack. First principle: graceful shutdown is the contract. Every supervisor worth using, systemed, Kubernetes, Docker, sends SIGTERM, waits, then escalates to SIGKILL. Apps that handle SIGTERM are production grade. Apps that ignore it lose data on every deploy. Second, parents own their children. If you don't reap, you get zombies, which is precisely why container runtimes and process supervisors exist. And third, signals are 50 years old and still optimal. Kubernetes liveness probes, Docker stop, systems kill signal, all of them speak 1970s Unix. Stable foundations outlive trends. So here's your daily driver. 12 commands grouped by intent: inspect, find, monitor, signal, and jobs. Notice how it maps directly to the mental model we built. PS and STRI reveal the tree, grep and kill work by name instead of hunting PIDs. And the signal row goes from polite to forceful. SIGTERM, SIGHUP for reload. SIGKILL only when nothing else lands. Print this, pin it near your terminal, and in a month you won't need it anymore. Now it's your turn. 3 drills, 30 to 45 minutes, and the theory becomes reflex. First, walk the tree with STRI. So parent-child relationships stop being abstract. Trace your shell up to PID 1 and you'll feel the root. Second, play the signal escalation game on a background sleep. Send 1, 2, 15, then 19 and 18, and watch each one land in the stat column. Third, the senior move. Run ps-aux, ignore the CPU number, and read stat first to decide whether a process is healthy, looping, hung, or already dead. Once the drills are reflex, here are 5 mistakes you're now equipped to avoid. Reaching for kill 9, first skips cleanup and corrupt state. Escalate from SIGTERM. SIGKILL on a zombie does nothing. The process is already dead, so fix the parent that forgot to wait. Long SSH jobs die on logout unless you use nohup, disown, or tmux. SIGKILL on a dstate process queues forever. Fix the I/O, not the process. And never send a signal before reading stat. 30 seconds of measurement saves hours of recovery. And that closes lesson 03. You now reason from the process model, fork and exec build the tree, PS and top read it, signals flow through it, and jobs let you steer work in the background. Next up, stage 4 of foundations, files and I/O. We'll compose find, locate, redirects, pipes, and T, and uncover the streams running under everything. See you in lesson 04.